Boman Kemp has been producing galvanized area wells for over 50 years. In the year 2000, we received our first report of a galvanized area well that was showing signs of corrosion. Over the next several years, we had multiple reports of premature window well corrosion. This problem was occurring primarily in the Colorado and Utah markets. We dug up a number of these area wells and replaced them with new area wells, and to our surprise, the replacement area wells also rusted out in a short amount of time. Over the next few years, we spent a substantial amount of time and money looking for the cause of the problem. Our analysis included studying all of the materials and processes involved in producing our galvanized area wells. We found that the materials and manufacturing processes we had used successfully for decades were not at fault. In the meantime, we continued to stand behind our product while looking for answers. In 2005, we hired the services of QualCorr Engineering, a consulting company specializing in detection, diagnosis, and prevention of corrosion. QualCorr's research found that the failed area wells experienced rapid corrosion because a corrosion cell had been created. A corrosion cell occurred because there was a flow of electric current from the rebar through the area well and to the surrounding soil. 4 components are necessary for a corrosion cell to occur: an anode, a cathode, an electrolyte, and a metallic path connecting the anode to the cathode. When these 4 components are present, rapid corrosion can occur. In our situation, the window well is the anode, the rebar is the cathode, and the soil is the electrolyte. A metallic path is created when the area well comes in contact with the rebar, either through rebar touching a metal buck or on wall mount area wells when an attachment bolt comes in contact with rebar during the installation process. If the attachment bolts or buck are touching the rebar, a metallic path is established. If there is no metallic path, the circuit is not completed and a corrosion cell will not form. Therefore, the best way to prevent a corrosion cell from forming is to ensure the buck and the attachment bolts do not come in contact with the rebar in the foundation. There are 2 other factors that have contributed to this phenomenon and increased the chances of corrosion cells forming. First, new structural engineering requirements, which have substantially increased the amount of rebar used in new home construction. More rebar means more chances of inadvertently connecting the area well to the rebar. Second, UFR ground. The introduction to the electrical code of the use of UFR ground, which grounds the electrical system to the rebar in the foundation. The UFR ground and network of rebar function as an electrical conductor. QualCorr's research helped us to identify exactly what was causing the window wells to corrode. Their subsequent recommendations are based on the National Association of Corrosion Engineering standards. In summary, there are 2 things to do to help avoid the creation of a corrosion cell when installing an area well. Number 1, position rebar around a window in a way that the rebar won't make contact with the buck or the mounting bolts. With the considerable amount of rebar going into the foundation, this requires a little planning and inspection before the foundation is poured. If the buck or the attachment bolts end up touching the rebar, there is a high probability that a corrosion cell will be created. And number 2, conduct proper testing before and during the installation process to make certain that the buck, attachment bolts, and area well are not in contact with the rebar. Proper testing is ultimately the best way to ensure our products perform as designed and help you keep your customers satisfied.